Welcome to Metal Welding Lecture Series by Professor Joyjeet Ghose. This is the 11th lecture of the series. This lecture will be on laser beam welding, LBW. He will be discussing about laser beam welding principle, how laser beam is generated, types of laser, like gas laser, solid-state lasers, semiconductors lasers, liquid lasers, continuous wave and pulsed laser, CO2 laser, Excimer laser, ND, YAG laser, fiber lasers. Laser processing regimes is also discussed. Application of laser in manufacturing is also discussed. Characteristics of laser beam welding, types of laser welding are also discussed. Advantages, limitations and applications of electron beam welding are also discussed, so do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thanks.
Hello friends, welcome to lecture 11 of a series of lecture on metal welding processes. In this lecture, we'll be discussing about another very important welding process which is called laser beam welding. As we know, laser is nowadays a very important technology in our daily lives. Laser has wide applications. Even in manufacturing, we apply laser to a large extent. The manufacturing applications of lasers, I'll talk a little bit on some of the manufacturing applications of laser. But in this welding process, basically we use a laser beam which is focused into a workpiece, and the intense heat of the laser beam melts the metal where the laser beam strikes and forms a coalescence between the two metal pieces which you are joining. So that is the basic principles of the laser beam welding. The laser is made to focus, which is an intense light beam. The laser beam is focused onto the workpiece. At the power density, the beam width, when beam width or beam diameter can be very small, maybe in the range of 0.1 or 0.2 mm. So that much small diameter beam is made to strike. The power density is high. You can play with the power density and the exposure time, and you can do many things with laser. Particularly in welding, a particular regime has to be maintained between a relationship has to be maintained between the exposure time and the power density, and we can melt the metal which we are welding, and this welded metal, the molten metal comes together and forms a union, and the weld is completed. This is also another autogeneous weld. We do not add any kind of fluxing medium, do not add any kind of filler materials. We do not melt the electrode and melt it and deposit it. So therefore laser welding is also can be considered to be an autogeneous welding process. So no external material is added, therefore we obtain a clean weld, although sometimes shielding gas is supplied to protect the weld zone from atmospheric contamination. So what is laser? Laser is basically an acronym for light amplification by stimulated emission of radiation. So what is this stimulated emission and what is this amplification? So that will be, I'll be going into the slight details or rather slight basics of what is laser and how it is actually formed and what are the different types of lasers. So a small background I'll create before I discuss laser beam welding. So you should understand that laser beam is basically a coherent monochromatic radiation. So coherent means all the light is in, or photons are in single phase, and monochromatic means of single wavelength. So single phase, single wavelength light are collimated into a beam and made to strike the workpiece. So how laser is emitted? Okay, so certain material like lasing material, we call it lasing medium. So when this lasing medium is excited by certain source, maybe a light, maybe an electric discharge, maybe some kind of reactions, whatever it is, in some way if we excite it, so what happens sometimes electrons may jump to a higher energy level. Now when this electrons with the input of certain energy jumps to a high energy level, so that is a very unstable state, and the electrons always tries to come back to its lower energy state. So when it comes to its lower energy state, it gives a certain amount of energy in the form of photons. So these photons are emitted, and this is called spontaneous emission. Now this photon that is emitted goes around and strikes, it is reflected and it strikes the laser medium atom again, some other atom again, and it strikes the electrons from higher energy level to lower energy level. So in this case, each photon again strikes another atom, and it makes the electrons from higher energy level to jump to the lower energy level, and as such emitting more photons. So all such photons that are emitted are collimated or by certain lenses, so optical lenses, and made to focus on the workpiece or maybe used for certain purpose. But one thing is very important. Now to excite these, you can see diagrammatically it is represented here. So this electron jumps to a higher energy state. When it comes back to this state, it emits certain amount of photon. This photon again strikes another atom and strikes in such a way, knocks off the electrons from higher energy state to lower energy state. In the process, emits more photons. So all such photons are emitted are of single phase and are of single wavelength, which are you can say accumulated or collimated, right word, and focused into the workpiece or for any application, So that is how we use laser. And one thing is laser inversion, population inversion is very important. For laser to occur, you need a population inversion. Population inversion means you need more atoms to be at a high energy level. When more atoms in a lasing medium is at a higher energy level, we call it a population inversion. Now population inversion does not occur in nature. We have to cause it. Now to cause it, you require a pumping medium. This pumping medium, or the energy that is supplied, may be light, may be certain electric discharge, or some other medium. So that is you require a pumping medium and you require a population inversion. Okay. So what are the different types of lasers that we will be discussing? So you can classify lasers according to whether it is a gas laser or solid state laser, or semiconducting laser or liquid laser. Also laser can be a continuous wave laser and it can be pulsed laser. The pulse can be short pulse, long pulse, whatever it is. Again, pulse lasers of various types. We can classify lasers again according to the wavelength, visible region, infrared region, ultraviolet region, microwave region, X-ray region. So gas lasers, popular gas lasers are CO2 lasers, extremely popular. It can go up to around 25 kilowatt to around 50 kilowatt, and Excimer laser may be available up to around 100 kilowatt power. So Excimer laser and CO2 laser are extremely popular. Excimer laser use rare earth gases, or you can say halogen gases like xenon fluoride can be used as a lasing medium and can be used. So industrially, CO2 and Excimer lasers are gas lasers which are very, very popular. CO2 is much more popular than Excimer lasers. So here what we do is that we pump it through a high voltage source, and the discharge takes place, the lasing output is, and it is reflected, and through a lens slit holes the laser comes out. So Excimer laser. Then we have semiconductor or diode laser, and solid state laser, YAG laser. So this is neodymium, yttrium, aluminum, garnet laser. It is also industrially popular. So it is basically normally it is low power laser, normally around 500 watt or 1 kilowatt, 2 kilowatt, 3 kilowatt, 4 kilowatt, 5 kilowatt, maybe up to that region. So fiber laser is another popular, industrially popular laser, fiber laser, YAG laser. And then we have dye laser, which is industrially not that much popular, mainly used for some medical purposes, etc. Okay. So this figure that I am going to show shows laser processing regimes. I have said laser is widely applied in manufacturing industries. How we can apply depending on what is the power density of the laser and how much time we are exposing the workpiece material or the substrate material. So that is how we can control and use laser for different purposes, different applications in manufacturing. So this is the diagram. It's a very important diagram. It's a diagram between the power density. You can see it at 3 watt per centimeter square. So this is the power density. So it can go quite high, and this is the interaction time or the exposure time. So in this regime, it's basically used for thin film processing, where you can, let's say, around power density around 10 to the power 7, and interaction time is probably on 10 to the power minus 8 seconds. So very small amount of time you can apply laser, high power laser, and you can carry out thin film processing. And this is your laser glazing. You can somewhere around you can have laser cladding, laser alloying, shock hardening, laser drilling. This is laser beam machining basically. In this regime, around, let's say, around exposure time is less and laser beam power is very high. So at that high power and less exposure, so the the laser beam not only melts, it vaporizes the metal and creates a hole. So this is called laser drilling. And this regime, where the power is slightly less compared to that of drilling and exposure time is slightly more, we can go for welding purpose. So this is our area, deep penetration welding in laser. And this is transmission hardening. These are the various applications. Not only that, laser can also be used for metal forming processes. Laser can be used for brazing purposes. So laser has wide application in manufacturing. So it can be used any type of heating source. And laser, of course, is hugely used in your 3D metal painting. Basically, powder processing, 3D powder processing laser is quite often used in lens, in SLS, in DMLS. So all these processes use laser. So laser is very, very widely used technology in manufacturing. And laser based micromachining also very, very popular nowadays. So this is the regime showing different applications of lasers in manufacturing. So our concentration is in this region. So in 10 to the power 6, around 10 to the power 6 watt per centimeter square. So as I have said, laser can be emitted by various sources. It can be gas laser, it can be solid state laser. Gas lasers are CO2 lasers or Excimer lasers. Solid state lasers can be your YAG lasers, then fiber lasers. So those are the lasers that are normally used in welding processes. So basically the laser is made to fall, or the laser beam is made to strike. The concentrated energy of the laser melts the surface, and this molten metal then forms a union and the welding is completed. The heat affected zone is extremely narrow. The heat produced is also less, but the power density is very high, so we obtain deep penetration and very narrow. Also the cooling rate is very high in laser, just like your electron beam welding. The cooling rate is also very high, and that may lead sometimes for high carbon steel lead to cracking. So that is common to both electron beam welding and laser beam welding. So deeper penetration is obtained. Heat affected zone is very less. Again, there can be conduction mode depending on the beam width. There can be conduction mode or keyhole mode of welding. And the spot sizes can be of 0.2 mm to around 13 mm size. It can be pulsed or continuous. Now if you want to go for deeper weld, then you have to, exposure time has to be increased and the pulse rate has to be increased. The rate of pulsing has to be increased. So we can go for continuous mode or we can go for pulsed mode depending on the requirement. So it is very versatile process, welding of carbon steel, stainless steel, HSLA, steel, aluminium, titanium, etc. But remember, one thing is very important: reflecting surface like aluminium, copper is extremely difficult to weld. You can weld, but it's difficult because the reflectivity is high, absorptivity is very less, around 20% absorptivity, 80% reflectivity. So since the material reflects the light, So the heat is not actually absorbed. Also the thermal conductivity of these materials, copper, aluminum, is also high. So welding of copper and aluminum is difficult in laser beam welding. Also certain materials which are transparent, particularly polymeric material which are transparent, that is difficult to weld by laser beam welding. So you require an opaque material in order to absorb the light. So it is welding process popular in automotive industries. Again, I have discussed it can be of conduction mode and can be keyhole mode. So conduction mode and keyhole mode I have discussed in electron beam welding. Similar technique is used here also. So if you want to know about it, please refer to my previous lecture where I have discussed the conduction mode of welding and the keyhole mode. So application already I have discussed. Advantages is that laser can be transmitted through air, so no vacuum is required. Laser can be focused with lenses and mirrors, transmitted through fiber optic cables. Also, no direct contact between the workpiece and the weld is there, so only light is striking, and it can be carried out for different materials, not only metals. Non-metals can be welded by laser beam welding. Some limitations: equipment cost is very high, laser is dangerous, and so these are the limitations of laser beam welding. Nevertheless, laser beam welding and laser beam machining and other laser applications are extremely popular in manufacturing sector nowadays. So with this we come to the conclusion of this lecture. I hope you have enjoyed this lecture as much as I have enjoyed giving it. So thank you for watching this video. In the next video we will be discussing about ultrasonic welding.